Hello students, in this video I will explain the apparent depth of a liquid. This topic is from Ray Optics, chapter number 9, NCERT book of class 12th. As you can see from the figure, a person is looking at a fish. The real depth of the fish is much larger as compared to the depth of the fish which is appearing to that person. That means the apparent depth is less as compared to the real depth of the fish. Or in generalized way, you can say that a water tank appears shallower or less deep than what actually it is. This is due to refraction of light. Now let us study it in detail. Apparent depth of a liquid. For this, we have considered a water tank. Let O be the point object which is situated at the bottom of the tank. The depth of the tank is represented by HR, that is the real depth of the water tank. Or you can say the point object O is at an actual depth OA below the free surface of the water. This is the free surface of the water. Now, a ray of light incident on this free surface from the point object normally will move along the direction OA, as you can see here. That is, it passes straight as it is striking the surface normally. Another ray of light from the point object is incident at an angle I, and it travels deviating away from the normal. As you can see, the ray of light is moving from denser to rarer medium. That is, denser to rarer medium. It will move away from the normal like this, as is shown here in the figure. The angle of refraction is represented as R. Now, let us produce this refracted ray backwards. It touches the perpendicular ray at O dash. As this angle is R, this angle will also be R because these two are corresponding angles. Similarly, if the angle of incidence, that is the incident ray and the normal, consist of an angle termed as the incident angle, is represented here as I, then this angle will also be I because this is normal and this is also perpendicular. So these two are parallel to each other, and this OB is acting as a transversal. Hence, we can say this angle is also equal to I, that is, they are alternate interior angles. So, when this refracted ray is produced backwards, it is meeting at a point O dash. This O dash is appearing as a virtual image of O. That is, when we see through water, this O appears at O dash. So this is the apparent depth. O dash A is the apparent depth of the point object. Therefore, we have to find out the relation between this apparent depth and real depth. For this, we have considered two triangles, triangle OAB and triangle O dash AB, that is clearly visible from the figure. Let us first take the triangle OAB and find sine I. We know that sine I is equal to perpendicular upon hypotenuse. So sine I is equal to AB upon OB, as is written here. Now see in the another triangle O dash AB, sine R is equal to perpendicular AB upon hypotenuse O dash B, like this. Also, as the ray of light is traveling from denser to rarer medium, we can write down using Snell's law sin I upon sin R is equal to mu A upon mu B, like this. This can be written as mu A upon mu B, as the ray is traveling from medium B to medium A. Or even we can write down the reciprocal of it like this, that is sin R upon sin I can be written as mu B upon mu A. Now you can put down the values of sin R and sin I from above in this equation. So sin R is AB upon O dash B. When you will put down its value in this expression, see, it will come like this: AB upon O dash B upon sin I, which is AB upon OB. This AB will cancel and we will be left with OB upon O dash B, like this. As these angles are very small, so instead of writing OB, look at the figure, instead of writing OB, we can write down it as OA, that is, it is nearly equal to OA. And for these small angles, O dash B can also be written as O dash A. Now, what is OA from the figure? OA is the real depth of the point object and O dash A is the apparent depth of the point object. That means now we have calculated the ratio between real depth and apparent depth, that is equal to refractive index of first medium upon refractive index of second medium. Thanks for watching. Please like, share and subscribe.